Morning at the river's edge in the Amazon basin. Capybaras gather at the waterline to drink. The surface is calm, but right below that water, inches from the shore, something is waiting. The green anaconda is one of the heaviest snakes on Earth. Adults can weigh over 250 kilograms. That sheer bulk makes it impossible for the snake to chase down agile prey on land. It also lacks the venom of a viper, meaning it can't just bite an animal and wait for toxins to do the work. So we have a predator that is too heavy to run, entirely non-venomous, yet routinely catches some of the fastest animals in the jungle. Look at the skull. The eyes and nostrils are positioned entirely on top of its head. This precise anatomical placement allows the snake to monitor the shoreline while keeping 99% of its massive body completely submerged and hidden. Then it simply waits. An anaconda will lie completely motionless in the shallows for days, ignoring the current, waiting for the perfect moment. That extreme 250-kilogram weight is no longer a disadvantage. It acts as a heavy anchor, locking the snake securely in place for a silent ambush. Then, the waiting abruptly ends. In a fraction of a second, the snake lunges upward out of the water. This diagram shows what happens upon contact. The mouth is lined with distinct rows of backward curved teeth. If the prey pulls away, they do the work for the predator. The backward angle naturally drives the teeth deeper into flesh with every tug. Immediately after the strike, the anaconda throws its muscular body out of the water, wrapping thick coils tightly around the target. There's a persistent Hollywood myth that the snake crushes its victim's bones to dust during this phase. That doesn't happen. This cross-section shows what the coils are really doing. They function as a biological tourniquet, compressing major blood vessels. The pressure halts the circulatory system entirely. Blood stops flowing. Without oxygen reaching the brain, the prey loses consciousness in minutes. The kill relies on inescapable physics and targeted circulatory failure, rather than brute force destruction. Now comes a massive logistical problem. The snake has to swallow an animal whole that is much larger than its own head. This mechanical schematic of the skull explains how that's possible. Highly flexible ligaments connect the jaw bones, allowing the lower pieces to separate and stretch to extreme proportions. Swallowing and digesting a meal this size requires an enormous output of energy. But a single large catch provides enough calories to sustain the snake's basic bodily functions for several months. That massive, months-long energy reserve biologically offsets the extreme caloric cost of the ambush and the digestion process. An adult anaconda is a terrifying predator, but it doesn't start out that way. Young anacondas face entirely different rules. Before they put on their heavy mass, juveniles are just another rung on the food web, actively hunted by birds of prey, caimans, and jaguars. Statistically, only a tiny percentage of hatchlings survive the Amazon's gauntlet long enough to reach their 250-kilogram potential. Reaching that massive size is a rare, hard-won evolutionary triumph rather than a guaranteed birthright. When the rainy season arrives, the rivers overflow, turning vast stretches of the dense Amazon into a flooded ecosystem. These rising waters expand the snake's territory. The submerged branches and dark, tangled roots become an ideal, expanded hunting ground. The incredible weight, the top-mounted sensory organs, the agonizing patience, these are highly specialized biological solutions adapted perfectly to this watery environment. The green anaconda is a masterpiece of evolution, sculpted by the rivers to silently rule the Amazon.